Hello everyone, welcome to the online learning series. So we are in the session 4 of the chapter Motion in a Straight Line. In our previous class we have studied about the average speed and average velocity. So today in this session I am going to discuss some numericals on this topic. Before solving the numericals, so let us see what are the steps to be followed to solve any 5 marks problems. So whenever you have been given a 5 mark problem in your examination, so you should take down the data which is given in the problem first. Then you should write the relevant formula. So writing the formula is very important because formula contains 1 marks. After writing the formula, you should see what are the things you have to calculate. Then substitute the values and get the answer. So while writing the final answer, you should mention the SI unit for all the physical quantities. It's very important to mention the SI unit of all the physical quantities. Now let us start with the first problem. So in the first problem, so a boy starts from his journey from the home and he runs to a market which is 1 kilometer away, and the duration taken by this boy to run from home to market is like 30 minutes. Then he sees that the market is closed, so he comes back. While coming on the way, he finds his friend's house and he stops here. So his friend's house is half kilometer away from the market, and the duration taken for him to reach his friend's house from the market is 15 minutes. Now for this case, they are asking you to find the average speed and average velocity. The first thing you have to do is take down the formula. What is average speed? Average speed is the total distance travelled by the total time taken. So this is the formula. So first we have to find out the total distance travelled. So the total distance travelled by the boy is, he starts from home to market which is 1 kilometer away, from market to his friend's house which is half kilometer away. So the total distance will be 1.5 kilometer divided by the time taken by the boy to reach the market and then to his friend's house is, the total time duration is 30 minutes plus 15 minutes, it is 45 minutes. Now coming to this, here the time duration is in minutes. I am going to convert it into hour. So to convert it into hour, it is 45 minutes. We know 1 hour is 60 minutes, then 45 minutes will be how many hour? 45 by 60 hour, which can be written as, this is 15 3s, 15 4s, 3 by 4 hour. Now this can be written as 1.5 into 4 divided by 3 kilometer per hour. 1.5 ones are 2s, 2 ones are 2 2s. So the average speed is 2 kilometer per hour. Now let us find out what is the average velocity. Let us calculate the average velocity. Average velocity is given by the formula total displacement by the total time taken. What is the total displacement? The boy starts his journey from home and he has ended it at his friend's house, and from his house to his friend's house the distance is half kilometer. That means the displacement should be, in case of displacement you are only going to consider the initial position and the final position. So the displacement is half kilometer in this case. So this is 0.5 kilometer by the total time. Total time will be the same for the complete journey has taken 45 minutes. The same thing we are going to take down. The total time will be 3 by 4 hour, and this is equal to 0.5 into 4 by 3 kilometer per hour, and this one will be equal to 1s are 6s are 2s are 3s are, so this is 0.2 by 3 is 0.67 kilometer per hour, and this will be the average velocity of the boy. So while solving these problems, the thing you have to remember is whether all the quantities are in the same system of units. If they are not in the same system of unit, then you have to make certain conversions. So you should bring all the physical quantities to the same system of units, either CGS unit or SI unit, and then solve the problem. So one example is, if you have the physical quantity like speed or velocity in kilometer per hour, then you can make conversion to the meter per second. So you can convert this unit which is in kilometer per hour to meter per second. So let us make this conversion. 1 kilometer per hour will be equal to 1 kilometer is 1000 meter divided by 1 hour is 3600 seconds. 0 0 gets cancelled, 2 5s are 10, 2 18s are 36. So 1 kilometer per hour can be written as 5 by 18 meter per second. Remember this conversion, we are going to usually use this conversion wherever we have kilometer per hour, we can just convert it as meter per second by multiplying 5 by 18 to it. So let us move to the second problem. Here in this problem, a car travels with a speed 30 km per hour in the first 5 minutes, and then the car is going to change its speed to 40 km per hour in the next 10 minutes. So what is the total distance travelled by the car and the average speed of the car? This is what the question is. So you can use the calculators wherever necessary. Let me first calculate the first case in which the speed of the car is 30 km per hour and the time duration is 5 minutes. So since the system of units is different here, it is in kilometer per hour but the time is in minutes, I am going to convert this minutes into hour first. So to convert, I am just going to divide it by 60. So 5 by 60 is 1 by 12 hour. So we have made the conversion. Now to find the total distance, I need to find what is distance first. In this case, distance S1 will be equal to V1 T1 because velocity is distance by time. So distance can be written as speed into time, V1 T1, which is equal to 30 into 1 by 12. So 30 divided by 12. 12 ones are 12 2s are 24.6, that is 5 kilometer. This is 2.5 kilometer. Coming to the second case, here the velocity is 40 kilometer per hour and the time is 10 minutes. So first make this conversion, divide 10 by 60, this is 1 by 6 hour. Now you can find the distance in this case. Distance is equal to V2 T2, V2 is 40, T2 is 1 by 6. Now 6 6 are 36.40, 6 6 are 67 kilometer. So here the distance travelled is 6.67 kilometer. We have got two distances here. One is S1 and the one is S2. Let me find out the total distance first. So the total distance travelled by the car is S1 plus S2, which is equal to 2.5 plus 6.67 kilometer, which is equal to 7 and this is 11, 3, 9.17 kilometer. So this is what the total distance travelled by the car is. that is 9.17 kilometer. Next, let us next find out the average speed. So, write on the formula, average speed is equal to total distance by total time. This total distance by total time. So, what is the total distance travelled by this car? 9.17 kilometer. And what is the total time? It is 1 by 12 plus 1 by 6. I'll solve this here, which is equal to 9.17 divided by, let me say the LCM is 12, then this is 1 plus 2, 9.17 divided by 3, let me bring this 12 to the numerator, then it is 9.17 into 12 divided by 3, which is 36.68 kilometer per hour. So, this is the average speed of the car. So, the next concept we are going to study is acceleration. So, if there is change in velocity, then the body is going to accelerate. Whenever there is change in velocity with respect to time, the body is said to accelerate. Acceleration is given by this small letter A. So, let us define the change in velocity with respect to time is defined as acceleration. And acceleration is change in velocity by time. So, what is its SI unit? Let us write the SI unit of acceleration. Since velocity is meter per second, we know the SI unit of velocity is meter per second, by time is second, therefore acceleration is meter per second square. Now, write the dimensional formula for this, m0 L1 T minus 2. This will be the dimensional formula. As we know, velocity is a vector quantity, acceleration is also a vector quantity. And velocity can take up values which are positive, negative or 0. Same way, acceleration can be positive, negative or even 0. Now, acceleration is of two types. One is uniformly accelerated motion and the second one is non-uniformly accelerated motion. Now, coming to uniformly accelerated motion. When is the motion said to be uniformly accelerated? When the change in velocity is constant. The change in velocity of a body in each unit of time is kept constant, then such motion is uniformly accelerated motion. So, the change in velocity per unit time should be constant. Whatever the change is going on in velocity should be the same in each unit of time, then such motion will be uniformly accelerated motion. Coming to non-uniformly accelerated motion. So, this change in velocity of a body in each unit of time is not constant, then such motion is non-uniformly accelerated motion. What is this change in velocity? The change in velocity involves three cases. The first one is change in speed. The second one is change in direction. And the third one is both. So, if you want to change the velocity, there could be change in the speed or direction or both, because velocity involves both speed as well as direction. So, even if the speed changes, velocity changes. Even if the direction changes, velocity changes. Or in some cases, if both of them change, like if even speed and direction both are changing, then we say that the velocity is changing. The change in the direction or speed should be constant. That is, if the body is changing its speed with unit time, that the change in the speed should be constant, or the change in the direction with unit time should be the same, constant. Then only we can say it is uniformly accelerated motion. So, whatever the change is taking place should be the same in each interval of time. Then only this will be uniformly accelerated motion. Otherwise, it will be a non-uniformly accelerated motion. And in this chapter, we are restricting ourselves to only the study of uniformly accelerated motion. We are not going to study about the non-uniformly accelerated motion. Whatever the motion we are going to consider is only about the uniformly accelerated motion. The next topic is average acceleration. So, how do you calculate the average acceleration? As the acceleration is change in velocity, average acceleration can be equal to V minus U by T. The formula for average acceleration is V minus U by T, where U is the initial velocity. Initial velocity, that is the velocity with which the body moves. The body starts its journey is what initial velocity is. Coming to V, V is the final velocity, and T is the time taken for this journey. Therefore, average acceleration is change in velocity, V minus U by T. Or you can say that these are the V and U are the instantaneous velocity at certain instant of time. Then I can write down average velocity as V2 minus V1 by T2 minus T1. That is, if the body is moving with velocity V1 in time T1 and the velocity of the body is V2 in time T2, then I can take down the average velocity as V2 minus V1 by T2 minus T1. Here V1 and V2 are the instantaneous velocity. So, the V1 is the instantaneous velocity at time T1, V2 is the instantaneous velocity at time T2. So, this is about average acceleration. Coming to instantaneous acceleration. As you know, if the body is travelling with uniformly accelerated motion, then the average acceleration and the instantaneous acceleration will be the same. And if this is not a uniformly accelerated motion and it is a non-uniformly accelerated motion, then the average acceleration and the instantaneous acceleration becomes different. Now, in such case, how do I define instantaneous acceleration? Instantaneous acceleration is equal to delta V by delta T, that is the change in velocity by time when the limit delta T approaches to 0. So, when this delta T, the time interval approaches 0, then whatever the velocity by time, the change in velocity by time you are going to consider, that becomes equal to instantaneous velocity, and this can also be written as dV by dt. So, I have explained this in your previous session. Delta is the change in velocity. D, whenever I write D, it is the very small change in velocity. So, dV by dt is also called as the derivative of velocity. We can say, call this as derivative of velocity. Therefore, acceleration is the first derivative of velocity. That means the velocity is changing with time. There is a rate of change of velocity with time is what derivative means. So, A is equal to dv by dt means the acceleration is the rate of change of velocity with respect to time. Or I can also write this as A is equal to dv by dt, which is equal to d by dt of, we know velocity is first derivative of displacement, that is dx by dt. Therefore, this can be written as d square x by dt square. Acceleration is first derivative of velocity, or acceleration is the second derivative of displacement, and velocity is the first derivative of displacement. Now, let us discuss the velocity time graph. So, what is velocity time graph? In case of velocity time graph, we are going to plot a graph by taking time along the x-axis and velocity along the y-axis. So, in the first case, so this is I have taken 5 cases of velocity time graph. In the first case, you can see we have a line, straight line, which is parallel to the x-axis. Already I have discussed, whenever the straight line, you have a straight line which is parallel to x-axis, then this means the slope is 0. Since the line is parallel to x-axis, here the slope will be equal to 0. Now, what is the slope in a velocity time graph? What is slope? Slope is change in y-axis to change in x-axis. In this case, what is the y-axis? It is velocity. So, it is change in velocity by the change in the time axis, delta t. So, delta v by delta t is nothing but acceleration. This is equal to acceleration. So, you can tell that a slope of a Vt graph is acceleration. Let us write down slope of a Vt graph is acceleration. Remember, the slope of a position time graph is velocity, and the slope of a velocity time graph is acceleration. Therefore, in this case, in the first case, since this line is parallel to the x-axis, I am going to consider slope as equal to 0. Slope is equal to 0, that just means acceleration is 0. If there is no acceleration, then velocity is said to be constant. The body is moving with constant velocity, where the body is not at all accelerating. The body is moving with uniform velocity. Coming to the second case. In this graph, you are getting a straight line where v is proportional to t. So, if you get a straight line like this, that just means the x-axis and y-axis are proportional to each other. That means for every change in the time, there is a same change, that is the velocity is changing proportional to the time. Therefore, we are getting a straight line, and in case of a straight line, the straight line slope is always constant. So, if you get a straight line like this, slope is constant, is said to be constant. That means acceleration is constant. Whatever the change in velocity with the unit time is taking place is same. The change in velocity with each unit time is same in this case. Therefore, I can say this is a uniformly accelerated motion. It is a uniformly accelerated motion. Coming to this third case. So, in the second case, as time advances, there was increase in velocity. Therefore, this is an increasing curve, and therefore, the slope here will be positive. But here, you can see as time advances, the velocity is decreasing. That means slope is negative. Slope is considered to be negative. But since it is a straight line, acceleration will be constant. The acceleration is constant and it is a uniformly accelerated motion. Only thing is the slope is negative, and we call such acceleration as retardation. We call such acceleration as retardation or deceleration. That means the velocity is coming to 0. The velocity has become 0 at this time. That means the body comes to rest at this point. The acceleration is decreasing. That decreasing acceleration is called as retardation or deceleration. Coming to the fourth case. Here we have a straight line. So you can say here the slope is constant. A is constant, acceleration is constant. This is a uniformly accelerated motion. But this one is different from this one because here this line starts from the origin, but in this case it is not starting from the origin. Here the body starts from rest. Here the body has certain velocity, initial velocity u. Therefore, this is a uniformly accelerated motion where the body starts from certain initial velocity u. Whereas in this case, the body is starting from rest. Coming to the last case, here you have a curve something like this, which is not a straight line. Then the slope of this curve is varying. At each point the slope is going to vary. So if the slope varies, then we say acceleration is not constant. Here the acceleration is not constant. Then this is a non-uniformly accelerated motion. It's a non-uniformly accelerated motion. So let me explain the instantaneous acceleration and average acceleration using these curves. So in this case, at every point the slope is same. That means acceleration is same. Then if you want to find the instantaneous acceleration at any point, it will be the same. Even here the instantaneous acceleration is same. Even at this point the instantaneous acceleration will be the same. Therefore, we say in a uniformly accelerated motion, average acceleration and instantaneous acceleration both are same. They are equal. Coming to this, where in case of a non-uniformly accelerated motion, the slope is different. At each point the slope will be different. Then the instantaneous acceleration becomes different from the average acceleration in this case. We now know the slope of a VT graph is acceleration. Similarly, the area under the VT curve is displacement. To prove this, we need to study calculus. But I am going to explain this using a simple method of a simple case where I have a VT graph. I have plotted a VT graph. I have this curve which is a straight line which is parallel to the x-axis, and we know the velocity of this is constant because acceleration in this case is 0. Therefore, velocity is constant. Let me say this is 0 and this is the velocity of the body u. And I will draw a line from here which is perpendicular to the time axis, and I am going to name this as capital T. And this is what the area under the VT curve will be. So this is the area under the VT curve. The shade which I have done in the blue chalk will be the area under the VT curve. So what is this area under the VT curve? It just looks like a rectangle. It's a rectangle. So let me find out the area of this rectangle. What is this area of this rectangle? Let me name this rectangle as OA BC. Area of the rectangle OA BC will be, you know, the area of rectangle is length into breadth. So what is the length? Here it is, I can take OC into the breadth as BC. Then this will be equal to, OC is the time taken, the time duration, which is nothing but capital T, into BC is the initial velocity, which is u. Here it is u into t. What is u? It is a velocity. T is time. We know the formula for velocity. Velocity is displacement by Time. So if I have velocity into time, what do I get? Whatever I get is displacement. Therefore, the area under the VT curve is nothing but displacement. In this session, we had solved some numericals on speed and velocity. We also studied about the concept acceleration, average acceleration, instantaneous acceleration, and we also discussed the VT graph. So, I'll meet you in the next session. Thank you.